Hi, this is Guillermo Campitelli, and I'm continuing with the case in which two numerical variables affect one numerical variable. We've been using linear regression, and now we are going to, in this video, see the model comparison approaches, maximum likelihood based factors, and the hypothesis testing approaches, and the typical NHST and the Bayesian version using Bayes factors as well. Okay, so let's start with model comparison. For maximum likelihood, we are going to use Jamovi, and so whenever we can use JASP, we use it. But here we need basically AIC that JASP doesn't provide, but Jamovi does. So we are going to do model comparison with Jamovi. So here is the data. What we have to do is to go to linear models, generalized linear models. Now we can use general linear models as well, because we are using a linear model. We are not using any other type of model. But linear model is one type of generalized linear models, and generalized linear models gives us the AIC, which if we use general linear model wouldn't give us. It does the traditional R square and p values, but here we want the AIC. So that's the only reason I'm using generalized linear models, because it gives us the AIC. Okay, so what we do is to put psychological well-being as dependent variable. Let me find it first. Here it is. And as covariates, we've got centered income and centered job of choice. Okay, so that's the traditional way of doing it. But here we are going to compare 4 models or 5 models. So we've got model 0, model 1, model 2, model 3, model 4, so 5 models. Model 0 is a model in which there are no effects of the independent variables on psychological well-being. In model 1, only income affects psychological well-being. In model 2, only job of choice affects psychological well-being. In model 3, both income and job of choice affect psychological well-being. And in model 4, both variables affect psychological well-being, but also it assumes there is an interaction between between job of choice and income. So we've got those 4 models. Now, for model 0, we don't have a way of getting model 0 in Jamovi, but I found a way of doing it. So basically, I created a variable that sorry, this is JASP. So here is Jamovi. I want to show you the data. See if I press this one. So I created a variable called ones. What this variable has is just ones, number ones for all the rows. So now I'm going to create a model in which the only variable affecting psychological well-being is the variable called ones. Because this variable doesn't have any variability, it's the same as being a null model. So the only reason I want to do that is because I want to get the AIC of this model, and the other models should be better than this one. Yeah. Okay. So I've got to linear models, generalized linear models, for the dependent variable psychological well-being, and as covariates on the variable ones is here. Okay, so here I've got the AIC, which is 2269, and that coincides with this column, in which I've got the AIC 2269, and basically what it does, the beta 0 here will be the mean of psychological well-being. Degrees of freedom, we've got 300 observations, and in order to calculate the mean we lose 1 degree of freedom, so that's why it's 300 minus 1, 299. Okay, let's see model 1. Model 1, instead of having ones, we put centered income. So centered income as covariate, and we've got the AIC 2258.8, and we've got here the intercept, and we've got the slope, or beta 1 for centered income. But most important, because we are in model comparison, we want to see the AIC of the whole model, 2258.8. Okay, we do the same with center job of choice. Again, okay, get the AIC 2194.5. Now we do the two variables together, and we've got 2186.9. And then for the other model, for the one model 5 or model 4 with the interaction, we need to do this and pass it as interaction. So it creates an interaction, and we get the AIC 2188.8. So altogether we've got the models, we get the parameters, but in model comparison we are more interested on the AIC. So basically that shows that the best model is model 3, which incorporates both variables, income and job of choice, and has the lower AIC. When we add an interaction, the model doesn't improve at all, it goes worse. So it increases very tiny the fit, but because we lose 1 degree of freedom, that is penalized, and you get 2 more points. So basically model 3 is the best model, and it's the one we prefer. Okay, so that's the maximum likelihood approach. Now let's move on to the Bayesian model comparison. So we are going to use the Bayes factors, and the software is JASP. Okay, so let's go to JASP. So we've got regression, Bayesian linear regression, and again we've got psychological well-being, and the covariates should be center income and center job of choice. Now we've got here we got the table with the Bayes factors. So here is comparing to the best model, but we prefer to compare to the null model. That's what we are looking for. So we've got the null model, and then the Bayes factors. So that's model 1 that compares model 1. So the Bayes factor here compares model 1 versus model 0. and that's the base factor of 52. This is model 2, job of choice, and compares model 2 versus model 0, and it has a number with more than 15 zeros. 15 digits, I would say. And the model with model 3 here, it's a bit better than this one. We've got one more digit. So these are models. All these base factors compare the models to model 0. If we want to compare models between themselves, we have to obtain the ratio of these base factors. So here we've got the same table, and for base factor 2, 1, we do the base factor 2, 0 here, divided by base factor 1, 0, this one, and that gives us the base factor comparing model 2 with model 1. If we want to compare model 3 with model 1, we do the base factor 3, 0 divided by base factor 1, 0, and if we want to compare model 3 and model 2, we do base factor 3, 0 versus over base factor 2, 0, and this is the base factor. So basically, both model 3 and model 2 are much better than model 1, and model 3 is 12 times better than model 2. So model 3 is the preferred. Okay, finally we move to hypothesis testing. So for the null hypothesis statistical significant testing approach, the traditional approach, we can use JASP, and we do the same regression, linear regression, and the only thing is that we are going to concentrate in different aspects. So if we go to regression, linear regression, we'll do again, then we get psychological well-being as dependent variable, center income and center job of choice as covariates, and now basically we need to concentrate in these. We can also add the interaction, and we see the table here. I've got it better in my slide here. So basically, when we do the null hypothesis testing, we have the hypothesis that income affects psychological well-being, job of choice affects psychological well-being, and that the interaction is different than 0. So basically, these are the hypotheses. So for that, we don't have to worry about the whole model, if the model is how much it accounts of the variance accounted for by the model. We look at the individual variables. So in order to do that, instead of I mentioned this in previous videos, instead of obtaining a sampling distribution of the betas, which is not known, the betas is transformed into t-score, and the t-score we know we've got the t-student distribution, and so we can determine how probable is to obtain this score 3.11 here if the sample comes from a population in which the effect is 0, and that probability is less than 0.05, so we reject the null hypothesis and we determine that there is evidence for income affecting psychological well-being, and the same for job of choice. the t-value is 9.09, and it's even less likely that this score or a higher score, a more extreme score, would be found in this sample if in the population the effect is 0. On the other hand, the interaction, the t-score is 0.17 and the p-value is very high, so basically we don't reject the null hypothesis. So we reject these two hypotheses, but not this one. Finally, the hypothesis testing using Bayes factors. This is the same slide as the one I showed before for model comparison. So in the model comparison, we concentrated in comparing models 3, 2, and 1, but this same table gives us the Bayes factors against the null model. So basically, if this Bayes, what we can do is this. So if we want to know whether income affects psychological well-being, we look at these Bayes factors. So 52, there is strong evidence that very strong evidence that income affects psychological well-being. If we want to see whether job of choice affects psychological well-being, we look at this Bayes factor, and it's extremely strong evidence in favor of that. And so that sometimes we want to know, it may be the case that the two variables share a lot of variance, so they are very similar, and they both affect psychological well-being, but because they measure the same thing. So we want to know whether one variable affects, if when we add the two variables together, if this is better than the two variables individually, and in that case you have to compare this is model 3 versus model 2, and model 3 versus model 3 versus 2 and 3 versus 1, so these two, to determine whether having the two variables together improve the likelihood of the model, and it does. So basically, what it's saying is that they both the variables independently affect psychological well-being. Is not a shared variance. Okay, so this is the end of the video about model comparison approach and hypothesis testing approach using the traditional and Bayesian methods.